Here's problem 3045. A long solenoid, 1500 turns per meter, carries a current of 20 milliamps and has an inside diameter of 4 centimeters, which means that everything else is going to have to fit inside that. A long wire carries a current of 2 amps along the axis of the solenoid. What is the magnitude of the magnetic field at a point that is inside the solenoid and 1 centimeter from the wire? Let's consider the wire first. We have this wire, and it's carrying a current of 2 amps. And because of it's carrying a current, there'll be a magnetic field going around it from the right-hand rule like this. And the value of that magnetic field will be mu naught I over 2 pi r. Now let's enclose this whole thing inside a solenoid. So the solenoid has currents going through its windings, and hence the solenoid will have a magnetic field along its axis equal to mu naught little n times I for the solenoid, little n being the number of turns per length. So the magnitude of that magnetic field, which is mu naught little n current of the solenoid, is going to be 4 pi times 10 to the minus 7 times the number of turns per length, which is 1500 turns per meter, times the current of the solenoid, which is 20 milliamps. So that is equal to 3.77 times 10 to the minus 5 Tesla directed to the right like that. Well, the magnetic field in the wire is going to be mu naught current of the wire over 2 pi r, 4 pi times 10 to the minus 7 for mu naught. The current in the wire is 2 amps, and we have 2 pi, and we're going to evaluate it 1 centimeter away from the wire, from the axis of the solenoid. So that's going to be 1 times 10 to the minus 2 for that. 4 pi divided by 2 pi is going to leave us with a 2. So we're going to have 4 times 10 to the minus 7 over 10 to the minus 2. So this is going to be 4 times 10 to the minus 5 Tesla. And it's going to be going circularly around. It's going to be perpendicular to the axis of the solenoid itself. So we're going to end up with this last magnetic field, the magnetic field of the wire, which is 4 times 10 to the minus 5 Tesla. And then we have the magnetic field of the solenoid, which is 3.77 times 10 to the minus 5 Tesla. And they are perpendicular to one another. So we really want the magnitude of this resultant magnetic field, which is going to be, we're going to have to use the Pythagorean theorem for that. So the magnitude of that field is going to be equal to 4 squared plus 3.77 squared square root times 10 to the minus 5. And that is equal to 5.50 times 10 to the minus 5 Tesla. So that is the magnitude of the magnetic field that exists at that point, or we could write it as 55 microtesla as the magnitude of the magnetic field that exists 1 centimeter from the axis of the solenoid. 55 microtesla.